Hello students, and welcome to the CompTIA Cloud+004 Exam Course brought to you by Third Level Technology. I am your instructor, Jim Herbie. In this episode, we're going to continue in Module 1 of the objectives discussing cloud architecture. This episode will cover Section 1.2. The topic is service availability. Let's begin. We're going to begin our discussion with resource regional availability. You might sometimes see this abbreviated as RRA. Resource regional availability is when a cloud service provider will ensure that there are services and resources that are defined and accessible in specific geographic regions. If you think about the United States, we have many different parts of the country: Northeast, South, West Coast, and in a resource regional availability framework, a cloud service provider will have different resources that will be accessed by different parts of the country. So for example, you may have different data servers that provide cloud storage for areas in New England, resource that is designated for users in the state of California. And in this type of configuration, we want to have very low latency for our users. When users are accessing their data in storage, if they're accessing a software application that is hosted by a cloud service provider, you want to have very fast times as far as your data access. We also will have to have local compliance. Depending on the location of your cloud resources, you have to abide by the residency and regulatory requirements for data within that jurisdiction. Another advantage of resource regional availability is faster disaster recovery. We can distribute our resources across multiple regions and allow our users to access other resources if our local ones have become unavailable or inoperable. Next, we have availability zones. An availability zone is when we have a single cloud region that will have multiple isolated data centers contained within. This allows us to have fault tolerance. We can distribute all of the workloads across different physical locations within the same geographic area. Availability zone also allows all of our cloud services and applications that we are providing to have redundancy. If one server or resource becomes unavailable for some reason, we can transfer the resources of the cloud service provider to another data center. It also allows our applications to have resiliency. If one data center is having an issue with the functioning of a software application, we can use a tool called failover. Failover is when we can transfer all of that application resource to another data center nearby and allow for access from that new center. Next, we have cloud bursting. Cloud bursting is a technique that we use when we have extended all of the capacity of our on-site resources. An example would be using cloud storage. If we have our users are reaching the capacity of memory or storage on our network at a specific point in time, we can temporarily transfer some of that resource to our cloud service provider. So for example, we could take some of our archived data storage that we have not used in a while, transfer it to our cloud server, and that frees up some space on our hard disk or solid state drive until we can get back to normal operating capacity. Cloud bursting is a tool that should only be used when we need those additional resources. A tool that is going to come at an additional cost to your business, but it does provide dynamic scaling if we need to extend a resource's capacity into the cloud. Next, we're going to discuss edge computing. Edge computing is when we try to bring our computational resources and our data storage closer to the location where it is needed. We're trying to reduce our latency and improve response times for end users. We are using edge computing in our Internet of Things networks. In IoT, we will have mesh networks where many different types of smart devices will connect to the same network. And we can use edge computing to identify areas on our Internet of Things network where we need to increase a specific type of resource. With edge computing, we also can reduce the need for constant cloud communication because we can store a lot of our data processing locally on the network. Next is availability monitoring. Availability monitoring is when we are tracking the performance of a specific cloud service. We want to see how is our network using certain types of cloud storage, web hosting, applications, and what type of uptime metrics do we have for these cloud services to our users. We want to use different tools and dashboards to create alerts and notifications when we have some type of service disruption. Another way we can protect our business is to use service level agreements, SLAs. SLAs are legal contracts between your business and the cloud service provider that the cloud provider will ensure compliance with certain types of data compliance and regulations. An example would be having proper encryption for health and medical data under HIPAA. Next, we have disaster recovery. You commonly will see this abbreviated as DR. Disaster recovery will be all of the strategies and solutions that our business will create whenever we have to restore a network service after some type of disaster or failure. If we have some type of natural disaster like a fire or a flood, we could have a ransomware attack, some other type of denial of service. All of these would be examples of situations where we need to have a disaster recovery plan. We've had some type of disruption and we need to restore a service to our users. The goal of disaster recovery is to create policies that will have business continuity and minimizing downtime. Disaster recovery will also focus on minimizing our data loss. We want to have very strong policies for data backups and replication of critical applications if something occurs that makes the service unavailable. Disaster recovery should have testing of your recovery procedures. You want to have the buy-in from your staff to have the proper knowledge and understanding of the proper steps when we have to initiate our disaster recovery plan. Next, we're going to discuss a couple metrics that are involved in the process of disaster recovery. The first is RTO, Recovery Time Objective. RTO, Recovery Time Objective, is the metric that will define the maximum acceptable downtime after we've had a system disaster. How long can a business go without a certain type of service before it is having severe impact to the business operations? Your RTO is going to give you the time window that you have to restore a service before your business starts to have some type of critical or severe impact. In your disaster recovery, you will have priorities to achieve your RTO. This will include all of your infrastructure designs as well as recovery efforts that you need to integrate together. Another metric is RPO, Recovery Point Objective. RPO will specify what is the maximum amount of data loss that is acceptable if we have some type of system disruption. So think about if you are at your own workstation. During your normal workday, you're going to be working on different projects and working on different documents and files. And you may have some type of power outage or system disruption, and you may lose certain amount of work. And that amount of work that you lose is going to be determined by how long has it been since you've saved or backed up your data. What type of data loss is just going to be part of the cost of doing business, and we're just going to have to recreate what was lost. That is your RPO. Your RPO is going to be determined by the frequency of your data backups. How often are you doing system backups, full copies, incremental backups, and others? And you need to determine what is going to be the impact of a data loss on our business operations. We also want to use our RPO to integrate with the RTO to make sure that we are focusing on good results for both. Next, we're going to discuss recovery sites. Recovery sites are different options we have if we need to recreate some type of network or IT environment after a severe disaster or disruption. Our first recovery site option is a hot site. A hot site is when we will have a mirrored copy of our IT network. It will be a fully operational data center that we can immediately use to take over our business functions. We will have a minimal downtime. It's just going to be the amount of time it takes to have our users get the hot site up on the network. With a hot site, we will have real-time data replication. We can have our hot site connect to our data backups to have instant access to all of our archived data as well as data that has been in recent use on the network. This is the most expensive disaster recovery option because you have a lot of investment in infrastructure, and it's going to be also the quickest way to get up and going. So it's going to be dependent on what is your budget in your organization. We also have a warm site. A warm site is going to be a partially equipped data center. It's going to be something that provides a balance between cost and recovery speed. When you are looking at a recovery site, there's generally two different categories. You have your hardware and your connectivity. Your hardware will be your computers, your printers, your servers. Your connectivity will be, can all of these devices communicate with each other? These will be your access points, your Ethernet cabling, your fiber optics, and all those aspects. In a warm site, you typically will have one of the two within the building. You'll either have the IT hardware or you'll have the network connection, and you'll have to bring the other half to the site. Normally, you will use your warm sites when you have to restore your critical applications very quickly, and you can use the infrastructure to get a working network environment back up. The third recovery site is a cold site. A cold site is when you will just have an empty data center. It's going to be a facility that will be immediately ready to get a network up, but you have to bring over all of your hardware equipment as well as all of your infrastructure to create network connectivity. This will be your most effective recovery option because all you're paying for is the rent for your site. But it's also going to be the longest recovery time because you're going to have to set up and configure both your hardware and your connectivity systems. And lastly, we want to understand multi-cloud tenancy. This is a very key concept when you are dealing with cloud service vendors. Multi-cloud tenancy is a concept that says we should never have all of our cloud resources tied to one vendor. The reason for that is that if something happens to that vendor or that business, all of our critical data resources could be lost or tampered with. So a good rule of thumb is to generally have at least 3 different cloud service providers so that if you have an issue with one vendor, you have 2 other ones that you can immediately turn to for your cloud resources. An example of this would be using multiple CSPs for your storage, using different cloud service providers for different software applications, as well as using your multi-cloud tenancy to distribute your workload across different providers. This allows you to determine what are the strengths and weaknesses of the different companies that are providing cloud services. That will conclude our discussion of Section 1.2, Service Availability. In our next episode, we will move on to Section 1.3 in the objectives and discuss cloud networking. We thank you again for following along in the episodes and course, and wish you best of luck in your studies. Enjoy the rest of your day.